So our section today is about similar figures. So this is kind of an introduction into some geometry concepts, things that you'll be doing in ninth grade in geometry class. So figures that have the same shape but not necessarily the same size are similar figures. So we look right here, we've got triangle RST. So do you know how we name triangles? So RST is named by the angles. Does everybody know what an angle is in a triangle? Has three angles. So if I'm looking at triangle RST, I'm going from point R to point S to point T. So that's triangle RST. We could also name it triangle STR or triangle TRS. Clockwise? No, you can go the other way too if you wanted to. Triangle SRT, triangle RTS. But the point is, when you name a triangle, so if I go R to S, hold on, let me do a better job. If I go from R to S to T, then when I talk about another triangle being similar, then it goes in the same order. So R has to be in the same position as X because they're listed first. So you see how angle R is 118 degrees? Everybody see that? Angle X is also 118 degrees. So the second one was angle S, and the second one here is angle Y. So look, S is 26 degrees, Y is 26 degrees. And then T and Z are last. So you see how T is 36 degrees and Z is 36 degrees. So it does not matter the order you name the first one, but you have to make sure the second one follows the same pattern, has the same angle in the same position. So what if I named the first one, what if I named it triangle TSR? Then what would I need to name the second one? Which angle goes with angle T?
Z, Y, X.
Z, and then S goes with Y, and R goes with X. Absolutely. So just when you name two triangles and you're calling them similar, make sure you match them up by their angles in the same order. If you don't, it's wrong. Okay, so what we call those, the angles that have the same measure, we call those corresponding angles. Do you know what corresponding means? It's kind of a big word. You've heard it before? Correspondence. That used to be like when you wrote letters to people. You said you corresponding with the other person. All that means is the angle that's in the same position. What we just got done talking about. So we just got done talking about corresponding angles. So you see how they say S and Y are corresponding, or an X are corresponding, T and Z are corresponding. These are angles that are in the same relative position. And then the other thing we have to talk about is corresponding sides. So if I was talking about this side, we would call this side SR, which is listed here. So which side goes along with side SR? Side YX. So I would say those are corresponding sides because they're in the same position. Side RT, what goes with side RT? Side XZ, right? You see how they correspond? So corresponding sides, those are sides that are in the same position. Corresponding angles are angles that are in the same position. And what I want you to notice is when we talk about a side length, you see how they put that little bar over ST? That's how you know you're talking about a side ST. And then right here, you see how you get that little angle drawing beside S? That's how we know we're talking about angle S. Just so you know, whenever I write angle, I will most of the time write my angles like that. I put a little drawing, I add that extra little side to it. And the reason I started doing that is because this by itself sometimes looks like less than, right, instead of an angle. So I always drew that so I knew I was talking about an angle. So just know if you see me do that, it's the same thing. It's what they're doing. Okay, so our big definition here about similar figures. So we kind of know what it means for something to be similar to something else, but in math, it has a very specific definition. If I have two figures and I'm saying those figures are similar, then that means that the corresponding sides, so we just got done talking about what corresponding sides are. So like side AB corresponds with side DE. Corresponding sides have to be proportional. So that means if I were to take the fraction that is formed between the two side lengths, they would all reduce to the same thing. So if this was 2, 4, and 6, then let's say in the other triangle, if that was 2, let's say this side length was 1. 4 would be 2, and 6 would be 3. You see how they all are scaled back by the same number? They have that same scale factor. It's basically like I took what I used to have and I divided it all by 2. Or you could think about going from here and multiplying by 2, right, to getting there. So when triangles or figures are similar, then their sides are proportional. So this is what that looks like. And you can see if I set up a fraction, like which side goes with side AB? We said it was DE. So if I did AB over DE, I would get 2 over 1, which reduces to be 2. Now what if I did BC? What goes with BC? EF. So if I did BC over
2.
EF, what does 4 over 2 reduce to be? It's 2 over 1 again, right? You see how both of these reduce to the same thing. The sides are proportional. That 2 over 1 equals 4 over 2. And that's what proportional means. You have a fraction equal to a fraction. Right? That's what we just got done dealing with. So that's the first part. Corresponding sides are proportional. And the angles have to be congruent. So do you know what the word congruent means?
It's the same.
The same. Congruent is just another word for equal. Okay, in geometry, when we talk about the measure of something, if the measures are the same, we call them congruent instead of equal. But it is the exact same concept. Okay, there's no difference there. So two figures are similar if the corresponding sides are proportional and the corresponding angles are congruent. So in the previous example, if you'll remember, they had the angle measures. Like if this was 23 degrees, then it also told me this was 23 degrees. Okay, they're not always going to give you the actual measure. So you see here how angle A has this one little tick mark in it. And you see how angle D has one little tick mark in it. That's telling me those angles have the same measure. I don't know what that measure is, but I know they are the exact same. Then you look here, angle B has 2 of those tick marks. And angle E has 2. So that means those two are equal, are congruent. Okay? And then the same with C having 3 and F having 3. Are there any questions there? Now right here is how we say two triangles are similar in symbols. So you see they named the triangle ABC. This little squiggly line means is similar to. So this would say triangle ABC is similar to triangle DEF. And we know they are similar, so that means that the sides are proportional. So I have fractions equal to fractions, and the angles are congruent, which is basically an equal sign with that little squiggly line above it. Okay, so right here I'm given a trapezoid, and it tells me it's trapezoid DEFG. So if you trace it, DEFG, I'm talking about this trapezoid up here. And only one of the trapezoids beneath it is similar to trapezoid DEFG. And it wants to know which one is it. So what we can do is, we know similar figures have proportional sides. So we're going to set up fractions, set up proportions, and see which one is equal. Okay, so if I'm looking here, I'm going to set up my proportion as being EF. So let's first try this trapezoid here, PQRS. So which side goes along with or is corresponding to side EF? QR. So you see I did EF over QR. So I did one side from the yellow over one side from this one. Now I'm going to set that equal to, now what's the other side I know? I know side GF from the yellow. So what side does that go along with in PQRS? It goes along with RS here. Okay, so what we're going to do is we're going to now put numbers in for those values. So we know side length EF is 4. We know side length QR is 6. I want to know, does that equal side length GF, which is 12, over side length SR, which is 14. So you get two ways you can see if this works. You can reduce the fractions. So like 4 over 6, what does that reduce to be? 2 over 3. And then what about 12 over 14? What does that reduce to be?
6 over 7.
Okay. So do those two fractions reduce to the same thing? No. So that means that those side lengths are not proportional because they didn't reduce to be the same fraction. And again, if you think about cross multiplying, 2 times 7 is 14. 3 times 6 is 18. Does 14 equal 18? No. So I know then that PQRS is not the trapezoid that is similar. So now I'm going to try the next one. So I'm looking at trapezoid WXYZ. So again, I set it up just like I did before. So side EF is 4. Which side goes along with side EF? Is corresponding to side EF. In this one. Now it's side XY. So side XY has a value of 3. Equals, then I did side GF, which was 12 over, and then which side is corresponding to GF? ZY, which is 9. So now I want to see, do these fractions reduce to be the same thing? Well, 4 over 3, can that reduce? Not really. What about 12 over 9? Will that reduce?
4 over 3.
They're both divisible by 3, right? 12 divided by 3 is 4. 9 divided by 3 is 3. So those sides reduce to be the same thing. So that means those side lengths are proportional. So which trapezoid is similar to trapezoid DEFG? Okay, so I've got to name it. I've got to make sure it matches, right? So D matches up with W. E matches up with X. F matches up with Y. And G matches up with Z. So I would say trapezoid WXYZ is the one that is similar. Any questions there? Okay, so I'll do this one too then. If I look at the triangle DEF, the two side lengths I know are side DF and side FE, or side EF. So if I'm looking at triangle XYZ, which side corresponds to side DF? It would be side XY. And then which one corresponds to side FE? ZY or YZ. So then I'm going to set up my fractions and see if they reduce to be the same thing. So I'm going to do side DF, which is 6, over side xy, which is 8. And I want to know, does that equal side FE, which is 15, over YZ, which is 20? Okay, so 6 over 8, that reduces to be 3 over 4. And then 15 over 20, that reduces to be 3 over 4. So because both of my sides ratios reduce to the same thing, then that means those two triangles are similar. So I would say triangle DEF is similar to triangle XZY. Because again, remember we have to match the way we name them. So if I go D to E to F, I've got to go X to Z to Y. Yeah, so the way you did it is fine for testing if they are proportional or not. The only problem that y'all guys would have now, fraction equal to a fraction, we're going to cross multiply, set them equal to find the missing value x. 5 times x is 5x. 4 times 15 is 60. Now x is being multiplied by 5, so I divide by 5 on both sides. That tells me x equals 12. Right, and I should have put n, right, instead of x, but it's all the same. It doesn't matter. So my missing side length is 12 meters. Now be careful, because this time the triangles, they don't look the exact same, right? One's been rotated around. So remember, if they've told us the name, we know which one goes where. A matches up with E. B matches up with F, and C matches up with D. So just be very careful when you are setting up your proportions. Okay, so I'm looking for side length AC. Right, that's my unknown. So which side corresponds to AC?
ED.
It is ED. All right, and the way we can do that, remember, if I'm looking for A and C, match it up here with E and D. If you get confused, you can always go back to the name, and it will help you match them up. Because A and C is first and last, E and D are first and last. Okay, now which other side do we want to use? So we're going to use side length AB and side length EF. Okay? And again, see how those match? AB, EF. Okay, that works. So now we're going to set it up. Let's go AC, N over DE 3 equals AB 28 over EF 4.
Does it matter if you know
3 over N
3 over n?
equals 4 over 28? That works. As long as you start on the same triangle both times. Like you see how here I started with this triangle for N, and then I started with this triangle for 28, then I'm good. If you started with 3 and then 4, you're good. You just have to make sure you start with the same triangle both times. Okay? Now, fraction equal to a fraction. Cross multiply. 4 times N is 4N. 3 times 28 is
81, 84, 80.
I got 84.
84.
84. Now, N is being multiplied by 4, so I divide by 4. That tells me N equals 21. Which side matches up with x? Which side UV? Okay. This will be x over 7 equals. Then what?
20 over 4.
Yep. That's right. Cross multiply. That gives us 4x equals 140. Divide by 4. It tells me x equals 3, 5.
But I already broke this row. I got that right. I heard 7 over x. That's what I got wrong.
Pick a number 1 through 6. It's 6. Pick a number 1 through 2.
It's 2. It's 7.
It's 1.
Wait, don't do it.
She said she was about finished with it. I think ours is Thursday.
Wait, after that semester, we got school.
Where you got them?
Oh, I thought you said 10. Yeah, you said 10. You said 220 Okay, pay attention. Guys.
I did besides B and C and divided by FG.
Okay.
And I did 15 over X.
Okay, so we're matching up here and here. Okay.
And then I cross multiply, is that what you did?
Yep, cross multiply.
And then 13X and 585. And then I divided those by 13. And then 13, or X equals 45.
Very good.